All right, go.
Good evening, everyone. This is Ron Long, Vice President for the World Campus Tech Club. And it is 1 minute past the start of our meeting, or our presentation this evening. Tonight, we have Kai Pfiester, who's going to be talking about, did I pronounce that last name right, Kai?
It's Pfiester. That's fine though. No worries.
Okay, Pfiester. Around here, we pronounce it Pfiester, but it is Pfiester. All right, and tonight he's going to talk about the basics of how hackers evade antivirus and execute their payloads, thus compromising computer systems. And Kai is the founder of and chief security architect at Black Cipher Security in New Jersey. It's a security consulting firm based in New Jersey. He specializes in offensive security and holds numerous certifications from CompTIA, Offensive Security, EC Council, and Fortinet. As a speaker, he has spoken for the Philadelphia Bar Association for the attorneys, Philadelphia Bar Institute, Fox Rothschild, New Jersey Society of CPAs, and he is also an author and has written articles for the Pennsylvania Institute of Certified Public Accountants in New Jersey, and for Business and Industry Associate and BakeRate.com, and many, many more. Good evening, Kai. I'll hand it over to you, sir.
Thank you for the intro, Ron. So welcome everyone. Just to kind of set the tone, I like to keep things informal, right? So feel free to interrupt me at any time if you have any questions. This is a high-level overview because I don't know how technical any of you are. Certainly we can dive deeper, in a following or a follow-up presentation if that's desired. But essentially what I'm going to go over is, the general techniques, right? In how attackers, how red teamers, how penetration testers evade antivirus to gain code execution on computers and do other assorted things that they're not supposed to be doing on those computers. So with that said, let me start sharing my screen. So some of this is recorded and some of it is a live demo. So as we all know with live demos, sometimes things go wrong. Let's hope that Murphy is far away and we can pull this off. So let me see which one I need to select here. I think it's just my desktop. I'm going to share that so I can move in and out, right? All right, so there's that screen. But you know what? I don't think I did bring up the PowerPoint. There you go. Let's put that in presentation mode. Okay, can you guys see it?
Yes, sir.
Yes. Okay, excellent. All right. So today's agenda, I'm just going to go over, I'm probably going to skip over the introduction, right? Because you know who I am. Going to go into some of the terms, then the who and why of AV evasion, to give you a sense of, who actually does it and, what is the purpose of it, some of the basic techniques, and then I'm going to jump right into some demos, and then we can finish off with some Q&A. So just, again, I'm going to go over some basic terms to make sure we're all on the same page. So malware comes from the term malicious software, right? As you can see in red, the combination of those makes the word malware. Antivirus is designed to stop that software from executing, and then, as you can see here, evasion is simply the act of avoiding, right? So AV evasion is evading antivirus so you can execute your malicious software. So who evades antivirus, right? I'm just making a joke here because there are companies out there, big cybersecurity, and they always say it's China or Russia or Iran or North Korea, whoever our enemy is at the time. But again, attribution, as some of you may know, is virtually impossible, and these things are not very accurate at all. So as far as who would be evading antivirus, right? The first group is certainly cyber criminals, right? These are people that want to execute code to gain remote access to your computer to log your keystrokes, to exfiltrate data, potentially turn on your webcam and spy on you, take remote screenshots. Pretty much it's just espionage. Nation states do the same thing. Our national security agency, our CIA and FBI and all of that, they do it against our enemies. They do it to us. Obviously, there's mercenaries that get hired by corporations to perform corporate espionage, to steal trade secrets. And then there's law enforcement that is attempting to capture pedophiles and human traffickers and other hackers. And then there's people like me in firms like mine that do penetration testing. And then naturally there's security researchers, people that may work in higher education that want to learn about malware. They do reverse engineering and things like that. So they may take steps to evade AV. So naturally, the whole purpose of it, right, is to hack all the things. That's really why we want to evade it, so we can get our code executed. But first and foremost, on the legal side of things, it's really about demonstrating risk, right? You have to be able to show a business owner or any other organization, for example, such as a school or other nonprofits, that there are attackers out there. There are people with tools and techniques that are capable of performing espionage and things like that. Your everyday lay users of computers often are completely oblivious to what the bad guys can do. So just setting the stage of the environment, the testing computers here using Windows 7, Windows 10, and Server 2016. Depends on which demo I show. And the attacker computer using Kali Linux with Cobalt Strike. So as I know, some of you may not be familiar with Cobalt Strike. So Cobalt Strike is a commercial tool used for red team operations, right? So it's about $3,500, a year. So it's not cheap, but it's very powerful. As you will see, it's got all kinds of cool capabilities. So one thing I want to talk about is you see all this hype, right? All this marketing material. And, that's what these companies, these antivirus companies use to try to dupe people into buying their products, right? It's always some buzzword. It was AI, machine learning. The buzzword bingo goes on and on. But I just want to let you know that, despite the fact that we all need to use antivirus is not 100% effective. And if somebody wants to break into your computer, in most cases, they will be able to do so if they can trick you into executing code in some way. So let me see what we're going to get in here. All right, so your common AV evasion techniques, right? So the first one is just creating a payload, which is just a piece of software and executable, typically a portable executable that has no signature, right? The signature is really a big thing, right? It's like, as long as it's not a known bad, then it's always likely to be potentially safe as far as AV is concerned, right? Because they can't just block everything. They have to really kind of go on the known bad. Otherwise, anything new to them on your computer would end up getting blocked, even good stuff. So the next thing is file obfuscation, right? So the first thing I'm going to get into is cryptors there. So cryptors, essentially what they do is they encrypt the payload, right? So there's an exchange of public and private key, and the antivirus, in most cases, cannot get into it. And so it can't see the bad things that are going on. The way that AV will typically catch these things or alert on them rather is through the envelope, right? So the envelope in which the malware is encased will typically trip an alert because it's behaving in a suspicious way. And then there is encoding, which is not encryption, right? But what it does, an example is, sometimes antivirus will trip on, say, the word CMD if it is in lowercase. This is just a basic AV evasion. If you edit the text and you make it all capitals, or you make a capital C, a lowercase m, and an uppercase D, it will completely ignore it, right? So if you can encode data in that kind of way, for example, you can often evade AV. It's really that simple, just changing a character, right? Because it's pretty much black and white. Next is abuse of whitelisted apps, such as PowerShell, MS Build and CMD, and there's many, many more, which malware is leveraging, to execute. Next is packers. So essentially this is just compression of malware. When the file is compressed, a lot of the attributes of an executable are hidden, and therefore it's skipped by AV. Next is file splitting, is again breaking a file down into pieces, right? And you can analyze those pieces with AV. So just think if you had a file of 100 megabytes and you broke it down into 5 20 megabyte segments. If you analyze each piece with AV, you can find out which part it's hitting on and then make a slight change to that, and then you can get your code executed as well. So this is just an example. This is some, a couple, the most common ones, but there are many more. This is a huge topic in and of itself. So what I'm going to, I guess I can't really hear you guys if you comment, but Cylance is one of the more popular new next-gen antivirus products that claims to use this machine learning and artificial intelligence, that it doesn't require antivirus signatures. So it doesn't need to have a database of known bad. It can use its machine learning and artificial intelligence to identify bad things, even if it's never seen it before. So what I'm doing here is I'm showing you the portal. This is recorded, so I'm just going to let that play so you can see the settings for the agent.
All right, so this is the Cylance portal that you use to create the protection policies. So in this case, we are looking at the controls around file actions. So what it's going to do is it's going to auto quarantine abnormal or unsafe files. And then on memory actions here, it is set to terminate any activity that violates, things such as privilege escalation, process injection, exploitation, such as scraping of RAM, malicious payloads, buffer overflows, things like that. Protection settings, this is just for the agent itself and what it does, right? So it's going to prevent you from shutting it down and killing the service. It is going to kill unsafe processes and their sub-processes. It is running recurring. It's performing threat detection in the background, and it's watching for new files. Cylance Optics is their EDR. We are not using that here. Application control is, typically reserved for point of sale devices. Agent settings here, it just enabled desktop notifications, and here we have script control. Script control is typically not on Cylance because it breaks things in the environment. PowerShell scripts, JavaScripts, macros. So, typically in, corporate environments, it is not enabled. So with that said, let's move on to the target machine. here we've got the latest and greatest Windows Enterprise system. It was last updated at 2:29 a.m. It is 2:31 a.m. We've got the latest and greatest build of version 18363. And we have Cylance using the hacking testing policy to protect it. We are going to be leveraging Cobalt Strike as well as Coatic as our C2 frameworks. And with that said, let's get started. So here, we're just going to attempt to download some just regular out-of-the-box Cobalt Strike executable payloads, okay? This first one is going to be called malware.exe. I'm going to attempt to run it. I'm going to hit run, and Cylance barks. Next one we're going to try is payload.exe. I'm going to try to run that, and Cylance barks again. So, as we know, attackers don't just stop there. What do they do next, right? The most effective ways that attackers get into an organization is by targeting the employees with client-side attacks that leverage social engineering. What that means is that they send them emails attempting to influence them, trick them into aiding them in their attacks by either clicking on a link or opening a malicious attachment. So in this case, we're going to simulate, sending the user an email that is spoofed, pretending to be from the IT department that tells them that they need to update their browser because of recent security risks that were identified. So in that case, we would send them a link that looks like this. In this case, we have this from ads-global.net. They click on it and they see this pop-up that mentions securityupdate.hta. Well, they were already social engineered into believing that if they click on this link, it is going to update their browser. So if they click on it, they get another pop-up. In this case, it is mentioning that it's published by Microsoft. So this really helps with the social engineering because people tend to trust their computer manufacturer. So as we see here in the Cobalt Strike window here, there is no compromised computer, okay? When we click on this button, it's going to result in bypassing Cylance and breaking into the computer. So what we're going to do is we're going to interact, and we're going to set the sleep to 0 to make this session interactive. Now, we are also going to leverage, as I said, Coatic to carry out some additional post-exploitation activities. Okay. Now, if we go to the Coatic window, we see that it is waiting for an inbound connection. There is no established connection yet. Go back to Cobalt Strike, and we're going to hit enter. Now, shortly, you're going to see an inbound connection. As you see, Windows 10 test box, Windows 10 Enterprise has called back. Cylance has said nothing. Nothing at all, okay? So what we're going to do here is we are going to elevate our privileges. We're going to bypass UAC. And the way we do that is we're going to hit Use, Implant, Elevate, and we will use, say, FOD Helper, because that is still unpatched. Going to set our payload to 0, and we're going to hit Run. Now, bypassing UAC is considered an exploit, and Cylance is still quiet. Cylance is not saying anything at all. When we go here and we type zombies, it's supposed to have an S, we see here that we have escalated privileges with the asterisk. So let's do something else. Let's dump the SAM database from this computer. Okay, we're going to use implant /gather and hash dump the SAM database, which is the security account manager. And we're going to hit run. And we see that we were able to dump the LSA secrets. Well, at least some of it, right? syskey startup password probably in use. But the point being here is that we were able to bypass Cylance, elevate our privileges, and carry out additional activity. If we wanted to, for example, we can go back to Cobalt Strike and do things such as, take remote screenshots, right? So here, we come here, you can see that we are able to take a remote screenshot. You can do all kinds of additional things such as log keystrokes, exfiltrate data, etc. And that's pretty much it as an example of Antivirus Evasion.
Okay. All right. So I'm going to continue on unless there's any questions. So I'll give a second. Are there any questions?
Kai, this is Maria. I just had a quick question. You're showing this vulnerability inside PC or Windows, and I do believe that a lot of companies right now, even before, they still stick to XP and they still stick to Windows. Does this apply? This evasion, does this apply to some companies who basically migrate or upgrade their system into Mac? I saw a lot of companies who embrace Mac already. So is there any clarification on that matter?
Absolutely. Me personally, I use a Mac, right? So Macs are inherently much more secure. There is much less malware out there, but you should not interpret that as meaning that Macs are immune, right? So they are much safer. There's much less risk, but there is still malware out there capable of doing these same types of things to Macs. Does that answer your question?
Absolutely. Let me just follow up a little bit. Okay,
Yep.
If that's the case, then why cybersecurity? I can't find any cybersecurity blogs or any professionals out there that really encourage organizations to say, why don't we just go ahead and save us 1,000 bucks? I know upgrading is going to be expensive, but we avoid all this kind of phishing attacks, social engineering to our system. I haven't seen any of those suggestions.
Because humans suck at managing risk. So
That clarifies a lot.
right. So companies will say, right, your CFO will say, all right, it's going to cost us, $100,000 to do this. And this is a definite expense against a hypothetical what if scenario that may or may never happen. I can tell you, this is how they think, right? So you say, hey, you're going to be much more secure if you, switch to Macs instead of Windows. Well, that is a definite expense because you have to pay for the Macs. But the threat of an attack may or may not happen. And if it doesn't happen, you spent $100,000 for nothing. Does that make sense? That's how they think.
Yes, thank you.
Now, don't get me wrong, some organizations, we've seen, smaller law firms, they do things like that. But when you're talking about an organization that has 10,000 computers, you know, a several $1,000 Mac versus a $750 Windows, you know, laptop can become almost twice the cost. So let me see what I do here. Can't really remember.
Here's what was used.
Hold on.
In
Skim through here and see what I do. All right, so this is an office attack. All right, so a document attack, right?
So here's one last example. This one's using the same policy as before. It's on a Windows 7 box, and it is leveraging a document attack. So back to Cobalt Strike, right? You see that there's no infected machine, no compromised machine. And we're going to open this document called New Cybersecurity Protocols that we sent to the user from the IT department. And it just broken. Win7 test box. Just by opening the document. No need for enable macros, none of that. Just simply opening it. Same things can occur as before. Logging of keystrokes, remote screenshots, turning on the webcam, you know, exfiltrating data, all of that.
Okay, so I'm not sure exactly what I do here. Okay, so this was just an example. I'm not going to go through the whole thing, but Shelter, what it does is it allows you to embed a malicious payload inside of another executable. And so the point of this exercise is we take one payload and we upload it to VirusTotal, and we see that we get 30 or 30 plus detections as it being malware. After we run it through Shelter, we only get 9 detections. Right, so this is one tool, you know, that does that. If anyone wants to speak to me or, you know, ask some questions about Shelter, you're more than welcome to. But I'm just going to skip through all of this crap because I'm pretty sure you're not interested in seeing all of that. Let me just make sure. All right, so we choose this file and we upload it to VirusTotal. Get this right. Let me skip through here. Okay, so I actually did it backwards, unfortunately. So you see here that the use of Shelter made it much less detectable because we only have 9 AV engines that discovered it versus our original when we here. Come on, get this right. All right, so this is the one. Skip this, right? Keep going, keep going. All right, so we get about 30 engines there, right? So that's another example of AV evasion. Nope, let's move to the next slide here. Oh, where did I go? Okay, so I think that's the last slide before we get out of presentation mode. Okay, so I'll do a live demo, something, let's see, there we go. So, root. Okay, so there's this one. This is the live one. I was just using, because sometimes people ask me like, oh, you know, why aren't you using this other AV product? I mean, I'm not gonna, there's over 60 different AV products. I'm not going to test every single one. But in this case, I got, I think, what was it, Avast, right? So as you can see in this window, okay, there's no payload, right? And then in our Windows box, I'm just going to attempt to download this malware. And I'm going to get a failed to download, threat secured, and all of that stuff, right? Now, what's interesting is this piece of malware is the exact same malware that is inside the document. So we see that that failed, right? However, there's this evil document sitting here. And if you look to the left in the Cobalt Strike window, I'm just going to open this. You see right here, we get this immediate connection from the demo box. And Avast has nothing to say. Let's see if we actually scan the document. No issues found. So I want you to think about this, right? So you get something suspicious, right? Your gut is saying, I don't really know. I'm on the fence if this is good or bad. And then you run your antivirus, updates, and you say, all right, I've got the latest signatures. Now let me scan this file. And it comes back clean. And you're like, oh, okay, now I'm safe. You're going to think twice now, aren't you? It's very, very sneaky. And this is exactly how the criminals are breaking in. When you hear about all of these schools like Utah, University of Utah just got hit, this is what they're doing. This is exactly it. Now, the tool that they're using to do it may be a little bit different, right? But the method, the technique is the same, right? They send someone this document that says invoice.doc or something, the person is curious, they open it, it evades the antivirus, then they steal credentials from the machine, they move laterally across the network, they eventually steal domain admin creds, they steal data, and then they ransom the organization on Sunday night, so they come in on Monday, and they find out that they've been hit, okay? So I want to show you a little something, right? Because you're probably wondering, okay, what is it in that document, right? What is he doing in that document that is allowing him to break in? Well, under normal circumstances, the developer tab is not available, right, in the ribbon. You have to go to File, you have to go to Options, and then you have to go to Customize ribbon, and you have to tick off this, okay? Now what happens is when you're in the developer here, you can go into your macros, okay? Now if we look at this, remember how I was talking about encoding? You see all these, this is all the malware code. All this right here is all encoded. So the antivirus just sees a bunch of numbers, has no idea what's going on. Now you see there's all these numbers, and then it gets translated into running under rundll32.exe. Now watch this. What process is this? You see? But other than that, you can't really tell, okay? A better view of it is here. This little code right here that gets executed in the back of a document, it's so nasty, right? Remember how I was talking to you about whitelisted applications? I did not test this, but if any of you do network administration or anything like that, you're probably familiar. PowerShell, hidden window. this command, net object, net.webclient download string here. So what I'm going to do is I'm going to go on this I have no idea if this is going to work because I haven't tested it against this product. Now, if this works, we're going to see another window here. Okay, so it caught it, right? So when attackers are trying to break into a computer, or such as myself and my firm, what we do is we do some reconnaissance against the organization. We may even social engineer them and call them up and say, hey, would you be interested in buying this particular antivirus product? We'll call the IT department. And he'll say, oh, no, we're happy with our current, solution. Oh, yeah, well, what's that? 99% of the time, they're going to tell you, oh, we're using Symantec, or we're using McAfee, or we're using ESET. So once we know what they're using, we'll then practice, in developing payloads that we know is going to get around it, right?
Hey, Kai,
Yes.
I got a quick question.
Sure.
Now, that Word document that you had there, if you disabled macros, would that still infect the computer?
No, if you've gotten, and that's the whole thing, right? I mean, you can get very granular with your policies, right? You can say, okay, well, macros from, emails or documents outside the organization, right, cannot run.
Okay.
Right? You can disable them completely. There's, again, this is the whole thing about security, is that organizations often don't understand the threat, and therefore they don't take countermeasures, right? There's all kinds of things that, inside of a Windows domain and all of the policies that can be applied, you can significantly mitigate your risk against these kinds of attacks.
I see. Now, another quick question. Forensically, if I were to open that document with a hex editor, would the infection take place? And if it didn't, or even if it did, would I be able to look through the hex editor and see any header information that indicated that the document was not that document was infected or anything?
Well, I mean, you have to know what you're looking for.
Okay.
Right. I mean, that's what separates, a skilled forensic analyst, from nobody, from Joe Schmo. And when you're doing malware analysis, for example, you are going to perform it in a sandbox environment, right? You do not want to run the risk of it spreading. You can also set up, there's all kinds of tools that you can set up fake networks, right? So the malware actually thinks that it has a real victim, right? I'm not sure if you're familiar with this, but there's some malware out there that will not run because what it does is it has a check virtual machine module. So it checks, the CPU, it checks all of this stuff to see if it's running in a virtual environment, because typically that is where people are doing malware analysis at, right? Now that's becoming less so of the case now. They're using other things because virtual machines are huge in the enterprise now, right? So you can't say, oh, this is a VM, I'm not going to run. What they do is they look for things such as, how old are these accounts, right? What's the date on the account? When was this account created? Are there documents and other files, in downloads, on the desktop and things like that would suggest that it's a regular user, as opposed to someone just setting up a VM one day and then detonating some malware inside of it. Does that make sense?
Yeah. They're obviously getting wise to the antivirus. I mean, that's what this topic is about. It's antivirus, evading antivirus. So they're just getting wise to antivirus and getting wise to those that pay attention to malware, or try to detect malware outside the regular operating system. So
Yep, counter forensics.
Right. All right. Thank you, sir.
I have a
Appreciate it.
question.
Shoot.
I thought the other party was done. I'm sorry. Ram, was that you? Were you done?
I am finished. Thank you.
Yeah, no, I apologize. I did not try to cut you off. So I was using an antivirus product. I think it was semantic endpoint protection provided by Penn State. And Penn State's license with semantic expired on the 22nd. So they had kindly sent us notifications that we had to disable and remove it from our computer systems and find another solution at that time. So on the 22nd, I think I did it a day early. On the 21st, I removed semantic. I stepped away from the computer. I came back. I was downloading another product, another free product, Bitdefender, I think, and a window popped up. And it was a window that had, I got lazy. I don't think it was lazy. I think it was careless. So, I don't click on things I shouldn't click on. This window popped up and it had said something along the lines of something about inserting a USB drive or needing power for the USB port, something silly. And there was an OK box and I clicked OK. What I should have done was done a screen grab and not even clicked OK because I was in between antivirus applications. And of course, after I did it, I thought about it. I said, that might have been stupid because even though you're sitting here removing one antivirus application and trying to put in another, that would have been an opportunity for a threat actor to look at a machine. If for some reason there was a port scan going on and somebody saw I was doing that, could have served a window that was masquerading. So when I clicked on OK, which wasn't an action, saying install this software, I could have introduced malware. So after I installed Bitdefender, I ran a scan and didn't find anything. That doesn't mean there's not some, APT sitting on the computer. I mean, I have nothing to hide, so I really shouldn't be a target for that. But my point is, even when you're doing everything you can to try and be ultra proactive, you always have to be thinking. And it's so easy to have one errant click potentially expose you to, malware.
Correct.
Have you ever seen a message like that, by the way? Something oddball? I couldn't even tell you exactly what it says because.
But I can tell you that penetration testers, and if penetration testers and red teamers have these kinds of tools at their disposal, you better believe that the really, really bad people do as well. Yeah. So there are techniques that we use, for example, that will cause pop-ups to show up on your desktop and ask you to log in. Like there was an issue with your account, you need to re-authenticate. That is not Windows, that is us, right? And when you enter those credentials, we now have them. And we're going to use them to move around the network if those credentials work for that. So yes, things that, one thing to really understand and really try to ingrain in yourself is despite the fact that you see all of these stories, right, and these huge attacks, hacking is not magic. Right? It's not, this thing that is only wielded by, a certain group of people and it's so arcane that, no one can understand it. A lot of it is luck. You have, some very, very sophisticated actors that send, malicious emails, to, people in companies, and those people are just so aware that the attacks just don't work, right? A lot of it is luck, right? Even in, our law enforcement and our government, when, they are targeting, bad people of foreign countries, a lot of it is luck. It's like, okay, we're going to try this. Is it going to work? Right? So there's that component to it. A good example as far as cybersecurity is concerned is the analogy between it and the real world. If you are not engaging in risky behavior, for the most part, you can avoid getting harmed. If you're not out, at 3 o'clock in the morning in some dark alley in Center City, or, in some basement club somewhere, or hanging around with bad people, you're likely not going to find yourself in bad situations. However, does danger sometimes come to you? Do the people that want to carjack, the Mercedes that you happen to be driving sometimes go, to the convention center and look for people like you? Yes. Right? But that threat is very low. Even though it's possible, it's improbable. And so good cyber hygiene is very, very important. A lot of these organizations that get hit and end up in the news, they have a flat network. The users have local admin rights, right? Just when you find out the details of these cases, in most situations, they just have bad cyber hygiene. So, be paranoid, be proactive, be careful with what you're doing with your computer. But other than that, everything is up to luck.
I had the opportunity to take my internship got destroyed by COVID, so I had an opportunity to take a certified ethical hacker boot camp this summer, and I learned a bit. Sure, I was already aware of the human element being the weakest link in the chain, but this little incident that I was describing for you folks just illustrated that even when you think you're practicing good cyber hygiene, you think you're being careful, and in this situation, you're creating a vulnerability because you're removing one malware product or antivirus product before you're installing another, and usually you can't install both, so you have to uninstall one before you install the other. And in that moment of vulnerability, a window pops up, you take a quick look at it, it doesn't seem threatening, and you dismiss it, and you realize that even that act of dismissing it could potentially cause you a problem. It's just an opportunity to let other people know that you've got to be thinking all the time. You really have to be careful not to do that thoughtless click without looking a little deeper. So yeah, again, the weakest link in the chain.
Yeah, I would
Humans.
agree with you. There's always an opportunity for someone to do something bad. But again, if you take steps to engage in safe behavior and have good practices, right? Don't just click on anything. You really should have an attitude of deny all, right? Yep. Which is, if I don't really know why I'm getting this email that's asking me to do these things, don't do it. Really just interact with the things that you absolutely must interact with, right? But, the fact of the matter is attackers can be very, very slick. If you have a legitimate website, such as a portal for your university, and that, vulnerability, that website has a vulnerability, you can go to that. It's called a watering hole attack, where, they're expecting, people to visit a certain place. And when they do, they strike. And so just going to that website and clicking on the login portal or anything else, you can have potentially an invisible iframe, that can harm you. So, it's dangerous. The goal is to have good protection on your system and engage in good cyber hygiene, and you mitigate your risk as much as you can.
Just to verify, in the word settings, you want to disable what again? I didn't catch that.
Oh, you're talking about
the macro settings.
Yeah. So here,
is it the top one or the one you have checked?
Macro, actually, I'm not sure if this actually ran. Disable. Looks like macros were disabled.
That's crazy.
Yeah, some of this stuff is just, it's very nasty. You
If
know,
I understand you correctly, that's the machine or the VM that ran the script in the Word document, even though the settings are that it's supposed to disable with
well,
notification.
it's not a macro in the sense of allowing, you know how up here you would see enable macros?
Yep.
It's not even here. You know, you're not, it's a macro, but it's not a macro.
Okay.
Yeah, so guys, girls, men, ladies, don't open things you're not expecting. Do you guys have any questions? Is that it?
You had alluded to, and I don't, I'm not an officer of the organization, so I would ask if the people at Tech Club are interested in your offer, but the offer rather of possibly going into more detail, since as you pointed out, this was meant to be a high-level discussion. That's something I'd be interested in if it's something the officers want to entertain. And I'm sure there might be other people who feel the same way.
Thank you so much for speaking up, Kevin. This is Maria again. I agree. I second the motion. I totally agree with Kevin. If we can go ahead and go deeper, dig deeper a bit next time.
Okay.
If we have time, I guess. I don't know.
Sure thing.
Nick, do we still have time?
You have time.
No.
Yeah. So I would just have to schedule something just to let you know. I was supposed to do this, I think, back in July. I'm extremely busy, but I'm definitely open to doing something again. Just have to make sure that we have as much notice as possible for planning purposes.
So I'll let Ray know, and she'll reach out to you. Okay.
Okay. All right. Well, if there's no more questions, that's all I have to add.
Thank you for sharing your time and expertise today. It was insightful. Thank you.
You're very welcome.
Thank you, Guy.
Hey, thanks for coming out.
Good night,
Kai.
everyone. Sorry.
You're very welcome. And you guys, I believe, have my contact information. If there's anything I can do to help any of you, if you have any additional questions that come up afterward, don't hesitate to reach out. I'm very, generous with my time, especially with, young professionals that are trying to learn and grow in this industry.
Thank you.
You're very welcome. All right. Well, all of you be safe and you have a good evening.
You do the same.